Hello, my name is Rob Garner. I'm a software development instructor, and today I'm going to demonstrate how to add CRUD functionality to a Maui app using SQLite. So our objective is going to be to kind of reorganize the site a little bit to make this easier. We're going to store all our database classes in a specific data folder, so we'll be moving some things around. And we're going to create a repo just for the campus table. So right now that's combined into this overall school data access layer repo. And we're going to be adding a lot of more functionality to it. So in order to not clutter that up, we're going to make a specific repository for campus. And this will provide us the CRUD functionality to list campuses, add new campuses, update them, and delete them. In fact, that's what CRUD means: create, update, and delete, or retrieve, update, and delete. So this is the functionality that we're going to add next. And this will be our data structure, the folders that we're going to add. Here's the overall data demo project, and we're going to have a data folder with app settings, database service, campus, and campus repository. And then we're going to have our pages, which is going to be campus page and campus page XAML.cs. So notice we're going to be adding a model class for our campus. Okay, so our application is growing a little bit. I'm going to start using some branches. And I usually have a main branch, a dev branch, and then I start making feature branches. So I'm going to make a feature branch, which is add campus repo. And okay, so let's see, what do we want to do first? First, we want to make the data structure. So we're going to add a folder under here called data. And let's move all of these database classes in there. And it's going to ask us if we want to adjust the namespaces. I'm going to say yes. And what that's going to do is it's going to put it into a namespace, which is data demo.data. And usually you want your namespaces to follow the directory structure of your application. And so we're going to move that one and move the school repo in there. Again, I'm going to adjust the namespaces. And let's see, what else did we have? App settings can stay there, I believe. Oh, I think they put it into data. Thing is, there could be other app settings in here. So I think I want to leave that out, actually. And we're going to make a class called campus. And this class is going to have two auto-implemented properties, one for ID and one for name. So this is going to match actually what's in our database. If we go look at our database service, our campus has an ID and a name field. And just like that, we have an ID and a name field here in our model class. So this will be useful for us to hold information related to our class. And so this would represent one row of data. And so we're going to look at the app settings. That's got the name of the database, so we'll make sure that's there. And our database service is going to get that file name from the database, from the app settings file. Reviewing our database again, we have our database service, the DB path, a connection string, and initializing our database. And so this still exists. The next thing we're going to want to do is create a repo for our campuses. So we'll call this one campus repository. So we're going to add some code here. And the first thing note is that we're going to need a reference to the database service. We're going to insert that in through the constructor and store it here so that the rest of these methods can access it. And we have a get all method. And this basically makes a list of items. Actually, this is, let's rename this to campus. It doesn't like that. We'll leave it as items. So we create a new list of campuses here called items. We get a connection, which uses the database to get the connection string or database service. And then we open that connection. And here we are selecting ID and name from campus and order by name. So we're getting basically everything. And that's a string, which we pass to our SQLite command. We pass a connection, and that will, and then when we execute reader, this will use this to create a reader object that we can then read. So we're going to read from the reader, and then we're going to create a campus. So using this campus class, we're going to instantiate a campus object. And so now we're getting the ID and the name. So the first element at index 0 here, we're going to turn into, realize from the database, this comes in as just generic stuff that needs to be, we need to tell it what type it needs to be. So the reader, we tell it needs to be an int32, and it'll convert that to an int32. And then for the name, we're going to tell it we want it to be a string, and this is get index 1, so 0, 1, that will be name. And that puts it in here. And now our campus class has an ID and a name. And when we have that, we now add that campus we created to our items. So this items list is a list of campus. This campus is one. So we're just going to go through and read all the campuses that are in the database and add it to this list of items. Then we return that. So that's what this get all does. The get by ID takes an ID field, which is an integer. And again, we make a database connection. Our query now is select ID and name from campus where, and we're using a parameterized query. So what a parameterized query is it's a query where we specify in the query just that this is kind of almost like the SQL equivalent of a variable. We're going to make this command using this string and that connection. And then we're going to add a parameter to this command. And the parameter we're going to add is the SQL parameter. And then we're going to pass in the actual value that we do here. Now, there's a very good reason why we're using a parameterized query. If we don't, this opens up the possibility of a SQL injection security risk. So to prevent SQL injection, always use parameterized queries. Never concatenate something you get from the user into a string. Now, this one is relatively safe because this is an integer. If this was a string, however, the user could enter some SQL commands and it could be inserted. But just as a matter of practice, always add things that you're adding to a query that might come in from outside of a function in using a parameterized query. And so that means you put a name for it here, you put the identifier in the add with value method, and then you put the actual value that gets inserted. And the add with value will actually sanitize this input to make sure that it does not end up executing code within your query. And then now you'll notice that these definitions have these using directives. What those are for is when this goes out of scope, it'll execute a destructor, which with the execute reader and other things with like a connection actually contain a code to close the connection or to basically stop the read operation. So when you see these SQL commands with using directives, always use them with a using directive. It's kind of like a finally with a try except. In fact, some database applications you use try finally. The using directive does the same thing as the finally. It ensures that whatever this is gets garbage collected so that it doesn't keep connections open. And that's really important for database connections because while you can open up several of them, the number is limited. So you want to open databases, do work, and then close them as fast as possible. So here we are in our read operation. And in this case, we're only going to read one thing. So we're going to get the ID and the name for just, we're only doing it once. And then we're going to return a new campus from that. And so this basically read returns a Boolean saying whether or not there's another thing to read. If there are no more rows, it returns false. So if we don't get one, we just return null. If we do get one, we read it and return it. And we get back our campus. Okay, so then we have an add method. The add method takes a campus object, creates a connection. We open that connection. And then what we do is we create a SQL command that's insert into campus, the table, name and values name. So you'll notice that with the add, we are going to add with value just the name. So if you had multiple elements in your model or your table, it would be name, comma, and then all the other attributes. This table is pretty simple, so we just have to insert name. And then we notice we're executing non-query as opposed to executing reader. When you execute non-query, it means that you don't expect to get anything back from the SQL command, which we don't because we're just adding something. So we execute non-query. The update method is different from the add because instead of putting a whole new thing in, you're putting a new one in. And so notice that the add calls the SQL insert command. The update adds the update command. And then here it needs two things. It needs what we want to update and then also an ID field. Now, if you had more than one field, you would actually have multiple parameters that you put in here and you would add them all in here. The ID field, it needs to know which ID that needs to be updated. So it's going to pull that from campus.id. We execute that and that'll do the update. The delete also needs an ID, but it doesn't need the whole campus. We just pass in an ID field and then we delete from campus where the ID is there. We bring that in as a parameter, add it with value, execute a non-query, and that will do our delete. So those gives us all our insert, update, and delete methods in a nice, single, straightforward class. So the next thing we need is a page to work with that. So we're going to add a new folder. We're going to call it pages. And then we're going to add a new item, a XAML page, and we're going to call it content. We're going to call it campus page.xaml. I'm going to change this to manage campuses. And I'm going to add some UI in this page. So we're going to have a label, an entry for the name of the campus. And next to that, we'll have an add, update, and delete button and a clear button. And then we'll have a collection view of the campuses that will display all of the campuses. In the code behind, we're going to implement things we need. So we're going to have our database service and our campus repository that we created. And we need to know which campus we're selecting to edit in the page. So we'll provide that. In the constructor, we're going to initialize component as we normally do and instantiate a new database service. Pass that to our campus repo that will create this repo here, and that will be available throughout the application. We have a load campuses method that will set the item source for the campuses to the one we get from our repo. So when the constructor runs, it's going to run this. And that's going to go to this collection view, which is called CV collection view campuses. And then we have an add on click, and we're going to check we're going to get this one. When we add a campus, it's going to go to the entry for the name of the campus. And we're doing a few things here. We're going to trim the extra space around it. And we'll check, if it's a null, we'll check for a null here so that we don't do all this if it's not there. If this ends up, and then if it does end up null, we'll just put in an empty string. If it's an empty string, then we're not going to actually do anything. We're going to just, we have a status label there. We're just going to say, hey, you need to enter a campus. And otherwise, we're going to make a new campus, setting the name into it. Notice we don't mess with the ID field because the database will set the ID field for us. And then we're going to add the campus, load campuses. And if you're wondering why that happens, if you look at your database service, you'll notice that when we created it, we specified the IDs as primary keys. So what that will do is automatically set the ID field when you add anything to the database. So we don't need to set the ID field. It'll be set for us. In the on update, if we do an update, it's again going to check to see if the selected campus is null. And then it's going to basically get the new name and update it. We're going to do an update to the repo here using that code that we saw for updating the repo. That's going to update the database with this selected campus. Remember, and so selected campus is this field here. If we go delete, it's going to look at selected campus. If it equals null, it's going to give us a warning. Otherwise, it's going to do the delete. Now notice both in the update and delete, when we're done, we reload campuses. That's why this is pulled out into its own method, because every time we change something, we need to reload the table from the database based on what changed. And then here on the on clear click, if we're just going to clear the form, and we have a method down below to clear the form, and it just sets everything back to nulls and empty strings. And then we have an on-campus selected changes. So if we look at this collection view, yes, that there's a selection changed method here. And that's actually, when you click on it, it's going to change, it's going to set the selected campus. It's using the selected change events args. And in the case of selection changed event args from our event method, it has the ability to go to the current selection, finds the first selected item, and sets that as the selected campus. And then if it equals null, if it does not equal null, then what we'll do is we will we'll set the text controls name to what was selected. So that will update the text box with the name. And then in the status label, it'll tell us that it selected one. So that's how our UI works. We now need to make it so we can navigate to it. So the next thing is we need to be able to navigate to this page. So we're going to go to our app shell, and we're going to add another input for this page. And so this is going to go to the page we're going to call campuses, and it's going to go to campuses page. We also need to add a namespace for pages. So because we have this in this under this pages folder here, we need this namespace to navigate to this to campuspage.xaml. So we have that namespace. The other thing that we're going to do is, well, let's run this first, take a look at what it looks like. Looks like we need some some using directives, and try it again. If we go to campuses, now we navigate to campus. Let's see. Let's put Advanced Technology Center, ATC. And you can see here, when we pick these, it puts the information here. And we can update. We can clear that. Blah. Update. There it is, updated. And we can delete. So we have full CRUD capability on this page. And eventually this will, this is just kind of a demo of what's here. So there's not really doing much. And we can kind of leave it here for now, but eventually probably this home page will become a landing page. Actually, we'll just do that now. Let's go to our main page, and we'll simplify this a little bit. Yeah, we just need initialize component here. And so now our main page is just a landing page. And we're going to change that to, we're going to make this be a tab. So let's go to our shell again. And you have different you have different things that you can set up for the shell to the way it works. We're going to use a tab bar and see what that looks like. And now this gives a tab bar navigation, which is probably a little bit more useful for what we're doing. So this is an example of how we can, rather than having one repo that has everything in it, we're going to actually take these. We're going to split this out into multiple pages to which each have their own repo. So our campuses will have their own repo, our courses will have their own repo, our majors will have their own repo, and we're going to transform that to have everything be broken out. Okay, I went ahead and added repos for campus, course, and major. I got rid of the school repo because now it's all divided up into each of their original ones. One thing to note is the major repo is a little different because it uses the word title rather than name for its one field. And then I added a courses page and a majors page that's structured essentially the same as the campus one. And then in the app shell, I added tabs for each one of those, and then we run it. And now we have campus, and we have course, and we have majors. I can add a major. Let's see, data science. And so it works the same way. So we have our home page, and we have our courses, and probably we can update the main page to and just make this label a little bit more relevant. And so after completing that, I'm going to usually when I commit, I like to close all the tabs just to make sure everything's been saved. I'm going to commit all those and push it. And then I'm going to merge this back into dev. So I'm going to right click on this, merge into current branch. And so now the dev branch now features these new features that we added with that last change. And using branches that way is really nice because if this didn't work out, we could go back to dev and not merge it in and try again. And so that helps. So I highly recommend using feature branches. Just find and I usually use my development dev branch as my starting point. Create a new branch off that. Call it feature whatever. or F for feature, and then make the changes and then merge it back in. And that way, if I can try to implement something. If it doesn't work, my main branch, my dev branch is integrated. And then usually then you go to your main branch and eventually, actually typically what we do is from the dev branch, we create a QA branch. And we'll actually do testing on there and then merge QA into main. You may be wondering, why do we have all these branches? That's part of the normal development cycle of an application. Is the development team adds things to dev until it's ready to be tested by QA. You merge into QA. QA team tests it, and then then it gets pushed to main, and operations deploys the application. So push these, go back to main, or go back to QA, make sure that that's pushed, go back to dev, and then usually I'm sitting here on dev waiting for the next thing to implement. Thank you very much.